So in this session we will discuss about identity and ID functions. So in the last session we saw how the list and integer behaves very differently when with respect to references. So the question is why the lists and integers or strings behave differently. And we even gave the reason in the last session, saying that it's because lists are mutable, they can be modified, whereas integers or strings are immutable, they behave very differently. Let's discuss about this in detail. So all the values in Python, right, they have a unique identity that can be obtained using the ID function. So any value which is existing in the program will be stored in the memory, and a reference to it or the address to it can be accessed by using the ID function. So if you just type ID hello in your IDLE screen, now hello is a string that would be allocated a space in the computer memory, and that address of that computer memory we can get that by seeing this by just typing ID. And remember, this number keeps changing. That's because each time a different computer memory location can be available for that value. So every time you execute, the value can change. So this number what we are seeing here is actually the numeric memory address where the string is actually stored, and it is returned by the ID function. And as I told, it will be different each time depending upon where that value is stored in the memory. And as we know that hello is a string and it is immutable and it cannot be changed. So let's say if we want to change the string in a variable, then how do we do it, right? So let's say I assign a value hello to bacon, and if I see the ID of bacon, let's say suppose this is the memory address at which the value of bacon, that is hello, is stored. Now let me try to alter or modify this string, saying that bacon plus equal to world. So what is it actually doing? It is doing bacon is equal to bacon plus world, which is a string concatenation. That means I am concatenating hello with world. And now after modifying the string, if I see the ID, it will be actually in a different location altogether. That means what? If you change the string in a variable, a new string object is being made at a different place in the memory, and the variable now points to a different location. Let's see this in the IDLE screen. Suppose I say bacon is equal to hello. Now what's the location of this variable? Let's see by just typing bacon. So you can see that bacon variable is now stored at this address in the memory. Now I am trying to alter this. I am using this string augmentation operator. I am trying to concatenate the strings together. Okay, and now if I see the value at bacon, it is actually concatenated. But now if I try to see where actually bacon is stored, you will see altogether a different address. This address is different from this. So that means what? Any time you change the value in a string, a new string will be created at a different place in the memory. Okay, but the same does not happen to list. So let's try to do the same work, but with we'll do the same kind of functionality but using a list. So let's say now I will take a different variable, x is equal to some list values. Let's say cat, dog. So this is our list. I've created a list called as x, and if I see the location of x, now it is at this memory address. Now I'm trying to modify the list. I'm doing the same work. I want to do concatenation. So what I'll do is x dot append function. I will append an other value to the list. Let's say that. Now let me check the location of x. You can see that the address remains the same. Okay, so after modification of list, the address remains the same. It means what? Lists are mutable. So any kind of modification you do, it happens in the list itself. But strings are immutable. Any modifications you do, it will be done in a new memory location. Okay. So what you have to remember from this is, if there are two variables referring to the same list, which we have seen in the last session where we had spam and cheese, they were pointing it to the same list, and the list value itself changes, both variables are affected because they both refer to the same list. This we have seen in the last session in the program. And any kind of alterations that you do on your list, you can do appending on your list, which we just did, you can do extend, remove, sort or reverse. It will all happen to that list in place itself. It will not happen in a new memory location. Okay, and third important point that you should know is, Python's automatic garbage collector will delete any values which are not being referred by any variable. So automatic garbage collector will do that work. Any values which are not being referred will be freed up from the memory. So we don't have to worry about garbage collector work. We don't have to do any manual memory management, unlike other languages. So please try this. Please have a clear overview of this ID. So only when you understand this ID functionality, you can understand the next topic, where we will be discussing about passing references, copy and deep copying functions. Thank you.